So now that we know that a queue is really nothing more than a lineup, what are the operations that a queue can actually do? Well, let's compare it against the operations of a stack. We said that a stack and a queue are pretty similar, and they really are. The difference is, of course, how they operate with one another, or not with one another, but how they operate with their data. Whereas a stack uses that LIFO order, our queue is going to use the FIFO order, first in, first out. Okay, so what does that actually mean though? So let's look at our operations for a stack. We had push, which adds an item to the top of the stack. We had pop, which removes and returns the top of the stack. Top, which just returns the top of the stack. Size, it returns the number of items. And is empty, that returns true if size is exactly equal to 0. Otherwise, it gives us false. Well, the functionality, the operations for a queue are really the same basic operations. Add, remove, look at the front, return the size, check if it's empty. Nothing real different. They just have different names, and because of the FIFO versus LIFO, the actual execution is done a little differently, which means we get a different data structure and a different way of dealing with the data. So instead of push, we have what's called on queue. Okay, so this means add to the back. Sometimes called the tail of the queue. Great. Now we have Dequeue, which is the opposite of onqueue, of course. Dequeue, not the Dairy Queen, but it just means to remove. So remove and return the front of the queue. However, it also does one other operation that we have to realize. Everybody in the line, remember, this is just like a real life line. What happens when that person in front of you moves forward? Everybody behind that person has to move one space forward. So it will shift. So it then shifts all other items forward. Now, how this is actually done depends on which basic concrete data structure you're going to use to implement your queue. Are you going to use an array? Are you going to use a list? Or later on in the course, a linked list? So we have onQueue and Dequeue. And instead of top, we have peek. Think of it like the person working at the store who peeks at the front of the line just to see who's there. This one simply returns the front of the queue. Great. And then the other two are exactly the same. Size returns the number of items, and is empty returns true if size is equal to 0. So I'm just going to grab these two and just kind of push them both over here because they're 100% identical. There is zero difference. Okay. So we also have size and is empty. So let's talk about what the difference is. What's the difference between the stack and the queue in terms of these operations? Well, because we add to the tail and we remove from the front, that's different from always adding and removing from the top. The same element always gets dealt with when we're talking about a stack. But we're dealing with both ends of the queue when we're talking about onQueue and Dequeue here. So what changes depending on the data structure we use, with the concrete data structure? So if we're using an array versus a linked list, how does that affect things? Well, let's talk about the most basic one, which is the idea of onQueue. When you have an array and you want to add a new item, so if I want to onQueue the value 14, I simply need to go to the next element of the array, which is tracked with the size variable. So I could just say whatever the name of my array is, square bracket size equals the new item. That's all there is to it. That's the easy one. So onQueue is nice and easy. If I have a linked list, or sorry, not linked list, if I have a regular list and I want to add a new item, I want to onQueue, well, that's just an add operation, because the way a list works, when you add, it always adds to the end of the list. Well, that's perfect. That's exactly the functionality we need. But what about removing an item? What about removing an item from, what if we want to remove that front item of the array? Well, that brings in this part right here, which is shifting all the other items forward. If we're using a list, that happens for us automatically. We just have to use the remove at function. If you guys recall that. So for a list, we use remove at. And it's always going to be remove at 0 because we're always removing the front element. There's no change to this. This is always 0. Great. But what about for an array? Well, for an array, we don't actually have to delete anything. We just simply shift things forward. So imagine for a second I had this structure. I had 5, 6, 9, 1, 7, 4. And I said Dequeue. So what happens is the 5 is then removed and returned back up to wherever the Dequeue operation was called. Great. But what happens to the 6, 9, 1, 7, 4? Well, the 6 gets shifted forward. The 9 then gets shifted, and it has to happen in this order, because otherwise you're accidentally going to be overwriting your data. So every single element gets shifted one element forward. Okay, so shift. And this is a manual process. So that's literally like you doing a loop. So that's you doing a loop from, let's say, from 1 all the way up to size minus 1. And then what you're going to be doing inside of there, you're basically going to be saying array at I minus 1 is equal to array at I. Whatever array being the name of your array. Sorry, there should be square brackets, of course. So basically you're saying store the previous element of where I am. So I'm starting at 1. So when the very first time through the loop, it's going to say store in element 0 the value at element 1. And then it's going to go to the next value of I. Store in element 1 the value of element 2. So you can see how it's just basically shifting things over. So that's a manual process when we want to shift. So this is manual. And again, the list just does it for free. You don't have to worry about that. Peek is just obviously returning element 0 of your list or your array. So there's no special functionality other than that we need to realize. We do need to maintain our size variable. If we're using a list, though, we don't have to maintain the size variable because we can just use the count variable instead. All the other operations are exactly the same as they were for a stack. The size is that tracked value, is empty is just a comparison against the size, and as I said, peek simply returns the value at the front of the queue. If you go to Google Classroom, you'll find a programming example, and on that programming example, you're going to see all of these 5 basic operations using a list. Your homework is going to have you rebuild that same stuff, but using an array. So you're going to have to implement that shift operation. So that's it for queues. There's nothing else to learn about that. Now we just need to practice it and apply it. And your homework is going to definitely give you the opportunity to do that.